Okay, let's take a look at this example that uses the combination rule. Here's the question. You see it right there. Find the probability of getting 4 face cards, that's a king, queen, or jack, when 4 cards are drawn from a deck without replacement. Okay, and the answer is in front of us, but I'll walk you through it here. There are 4 kings, 4 queens, and 4 jacks, so that means there's a total of 12 face cards. The order and type of face cards don't matter in this question, so the combination rule can be used to find the number of ways to pick 4 cards. Now, here's the combination rule. It says the number of combinations of R objects selected from N objects is denoted by NCR, little n, C, little r, and is given by the formula there. Now, what's important to understand is the C just means we're using the combination rule. It doesn't take on a value. Okay, so what they say is for 12CR, that comes up to be 495. And for 52C4, which means what's the odds that from the whole deck, it comes up to be 270,725. Now, that way, the probability of getting 4 cards when 4 cards is drawn eventually comes out to be 495 over 270, 725. And if we take 5 out of the numerator, factor 5 out of the numerator and denominator, it reduces to the odds are 99 out of 54, 145. Now, let me show you how I work that over here so you can follow this. All right, we know that N is given by the population, number of objects. So in the first case, we're trying to select 4 face cards from a possible of 12, right? We came up with 12 here. So the N number of objects we have is 12. R is what we're trying to select, 4. What's the number of combinations we're trying to get from the total? And it's 4. Now, you need to take the factorial. We need to know what the factorial of N and R is to use the combination rule. Well, you can solve this slow way in Excel just by taking 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And that will work. So N factorial comes out to be 479 million and some spare change. But Excel gives us a nice formula to do this. It's called fact. So what you would do is you would enter equal fact, hit left parenthesis, and then put in the number. Now if you're looking up here, you could call it up, and then we put in the number. In this case, it was 12. Okay? And that will give you the answer. We're doing the same thing with 4. You can do it the slow way, 4 times 3 times 2 times 1, or you can enter equals fact and put a 4 in it. Now we know the factorials, we can compute the numerator. Well, the numerator is simply n factorial. So we pull from above, but the denominator is a little bit fancy. What we have to do is take the factorial of n minus r. That's 8. If n was 12 and r is 4, we've got to take factorial of 8, right? That's the first part, and multiply it times r factorial. And when we do that, we get factorial of 8 times 24, which was r factorial. So the denominator is 967,680. Now, if we want to divide that out, and you can see I'm just doing this in multiple cells in Excel so you can follow the steps, we come up with 495. Then we have to repeat the process to find out the total population. Now we figured out what's the odds of getting a face card. What's the total deck involved? Well, N is the total number of cards, and we're trying to select 4 from a total deck, right? So R becomes 4, N minus R would then be 48. Now, I'm not going to do the slow way, 52 times 51 times 50. That would take too long. So instead, I'll use Excel's equal factorial function. And I'll do that again for you. Equal factorial. Hit the left parenthesis, then you can put in the number, or you can come up here, click on the insert function. It'll pop up a window, give you a little bit of an explanation. We put in the number that we need, 52, total number of cards in a deck. And now we're expressing the answer, or the preliminary calculation anyway, in scientific notation, because that's a huge number. right? That would be 8 times 10, 67 places. It's a very large number. We don't need to express 4 factorial in scientific notation because the number is relatively small at 24. But 48 factorial, again, is another big number. Now remember, all I've done is change the format to scientific notation so that it won't just show up as pound sign saying it's too big to see. And then we can do the calculation, which is take the numerator, which is n factorial, given in cell J27, divided by n minus r factorial. Oh, and by the way, there's an extra calculation on this n minus r. That's the whole denominator. So it's n minus r factorial times r factorial. So we're multiplying it times 24. That's why we can take the denominator, the numerator divided by the denominator, and we come up with 270, 725. So the odds of probability of getting 4 face cards when 4 cards are drawn from a deck without replacement would be 495 out of 270, 725. Now they reduced it by taking 5 out. I'll show you how we did that too. Just divide 5 from both. And we get 99 out of 54, 145. But I'd like to go the next step and just divide that. And whether you use this number to do it, or these numbers, it doesn't matter. The probability turns out to be 0.18%. Okay? I hope you found that helpful.